I guess maybe not too obvious is because I said if you have we did not learn how to put this substituent, okay? We did not learn how to put that. We did not learn how to put this substituent, okay? So I'm just assuming that I have it already at the beginning. The other group that could be orthopara activating is if you have an R group. So that means that if I have this, so lone pairs, and then if I have this substituent, this is considered activating because if there's not a lone pair, there are no lone pairs, but the carbon is bigger than the hydrogen, so it's considered electron donating. That means that it can dump electron density onto the ring. It makes the ring more reactive than if you don't have a substituent. Okay? So if you have an H small atom compared to this metal, then this is going to be more an activator, the CH3 than just an H. Okay, so now what if, so we're now doing tri-substitution, tri-substituted benzene. We're synthesizing tri-substituted benzenes. So that means that we know how to make mono-substituted benzene, di-substituted benzene, and now we're going to do tri-substituted benzenes. So for example, so I have this, okay? I have a di-substituted, so remember we had mono, so if I have this and I put an electrophile, and then we know how to make this, okay? And then we know how to make, so if I put another electrophile, there are two things that can happen. So one is, so I have the original, I have an original electrophile, right? So if I now put another electrophile, so I put like this, okay? So the incoming electrophile is going to be dictated whether this is orthopara director or meta, right? So two things can happen. I have this, and then I'm going to have this either here, and then the other product is I have it, sorry. Okay, now this E can also be like this. Okay, so I just explained it, just explain what is referred to as orientation effect. You can have two things happening. This is a mixture, and then the other one is going to be the meta. So ortho-para, ortho plus para, and then meta. So it's separate, depending on what you're going to be adding as your electrophile. So now I'm now here, okay? And then we're going to go to the next substituent, which is going to be we're making a tri-substituted benzene. So now I have this example, and so this is a, so it's still, you have two positions, right? Is it gonna go here or here? So for example, so actually don't be confused of what the substituents are in the electrophiles. Don't mix up this information. So for example, I'm doing chlorination. Okay? So if you look at what we have, this is going to be meta director, right? It's gonna go here. But this one is ortho-para, but the para is already occupied. So that means that this position is reinforced. It's gonna go here. Okay? because this one favors the ortho, but the pair is already occupied, so you cannot replace this. And this one is meta-director, so this one is reinforced. That means that the chlorine is gonna go in this position. So this is the product. Oops. Okay, not here, because this one is ortho to this, but meta to that one. So this one favors the ortho, and this one favors the meta. Therefore, it's gonna go here. Okay, so that's the product. Okay, so actually, if you do so, let's do nitration. Okay, so I'm gonna erase this here. So I did chlorination, okay? So now if I start with the same molecule, so I'm not asking you for a mechanism, I'm just asking to write the product, and where the exercise is where is it gonna go, right?
Mm-hmm.
Okay, so CH3 and then NO2. And then I do nitration. So nitration is HNO3 and then H2SO4. Okay, so the same effect. The nitro, the NO2 is gonna go here. It's gonna go in here, right? Okay, so the NO2 replaced that H. Remember, there was an H. I replaced it. There was an H. Replace it. So I'm not asking you to write the byproduct. The byproduct was hydrochloric acid, right? Because H in a Cl. This one is going to be water. So I'm not asking. I'm asking for the organic product. So actually, if you continue, for example, sometimes it continues, right? You can make, so this one are favored because if you think about it, this position is ortho to this, meta to that one, meta to this. It's still slow, but you will get this, you will not get the NO2 over here. If you do another round of nitration, it's gonna go here.
This may be a stupid question, but why is it not NO3?
Okay, I'll explain. No, that's not stupid.
That gave me
That's not stupid.
that gave me a pause for a second too, because that's what I heard.
Okay. So you get these because actually this position, as I mentioned, this is reinforced because ortho, meta, meta. So in fact, but don't do this at home, okay?
Okay.
Don't do what at home?
In this reaction, I don't think you will.
Oh, like meth?
Yeah.
That's how you make meth?
No.
No, come on.
This is trinitrotoluene.
Yeah,
You don't know it, right?
You can poison
You know
your,
is
this
poison.
you
abbreviation?
can poison your loved one at, at Thanksgiving?
Yeah, right.
And the turkey.
Kablooey.
Turkey.
Turkey.
I won't let my brother-in-law know this formula.
So, this is not that easy to make because these are the activators. So, but you can still make it work because the activators NO2, it takes a while for that to react. Okay.
It's in fireworks.
Yes, and at home firework.
Are
I
there
love fireworks.
during
Well, this is-
Thanksgiving?
This is
There is
Yeah,
now.
why not?
Yeah, once
Not
I
at my
started
house.
There is not.
I like my house in standing, so no.
Add a little spark to the day.
Okay. So, so you understand the effect of the third round of substitution. So I'm gonna have another example. So can I?
We're trying to
one?
understand.
Then again, I could use a kitchen remodel.
You didn't tell me why it wasn't NO3.
Oh, yeah. Let me explain that. Anybody knows why?
It's water.
Yeah, but it's one H, that is O.
The,
Because
uh,
you're displacing.
The,
I know, I know, I know, I know.
No,
but-
no, I'm reminding
remember
myself
the
it's a question.
technique is
Gatorade.
you
Gatorade.
do this. So I just do NO2, right?
Yes. Okay, so it's one of those,
You cannot have
Oh,
three.
oh, look at that,
Okay.
tricky.
It's not a trick.
Well, it
So,
is.
so
So
the,
you have an
the
O
lesson
H.
here, you have to expand the structure. Otherwise, if you do NO3, because what you learn in your Gen Chem is NO3, it doesn't work here.
Right.
Okay, it doesn't work. So it has to be NO2 because
that
NO2, you cannot
double
have
bond.
NO3 bonded to a carbon. So it has to be like this. Okay, and a plus. So remember NO2, the N has a plus. The N has a plus, but the oxygen is a minus. Okay, so therefore, that's why I think I was explaining this earlier. This is electron withdrawing. Okay, the plus, you don't have a lone pair, you cannot dump electron density on the ring. It's gonna withdraw. So what is the resonance structure in here?
Always point to the plus.
Okay,
So go from the bond of the O towards the plus.
okay, and then, and then,
The plus
Plus
to
goes.
the other way.
right. Okay,
You're good at those dots.
so that's why
She's
the
had practice.
ortho, that's why the ortho is not favored, because the electrophile, it's a plus, it's not gonna go here. Or it's not gonna attack the electrophile.
Plus,
Do
plus.
you understand why NO2 is not favoring the ortho? Now, if you write another structure, if you move it, right? If you move this. So I showed that in the PowerPoint, but I think maybe I was going so fast.
Yeah,
Everything
it
was
was
like,
a little,
what?
it was a little fast, but that's okay.
Okay, so now
You're a
here,
professional.
plus, plus, plus on the end, dots, and then plus, okay? So these are resonance structures, this is not the mechanism, okay? This is
Just
just
resonance.
proving that the ortho and para are not available for the electrophile to make a bond. So I have another
So this one,
structure.
we just pick one, doesn't matter which side. does it?
It doesn't matter, but these are evidence or resonance structures to show you that the ortho and the para are not available.
Mhm.
They're less susceptible to attack by the electrophile.
No
So
vacancy.
like this, and then I have it here, and plus. So that's the explanation, Tiffany,
Okay.
why it's NO3, not correct, it's NO2. Why NO3 is not right. Okay, so, let me do.
It's a long explanation.
Few more examples about doing tri-substitutions, okay? So now, what if I have something like this?
I'm turning the page, new page.
Cl, okay? So where is it gonna go? So if you think about it, so now I'm doing alkylation. So say I'm doing this. AlCl3, okay? So I'm gonna do alkylation. So the electrophile here is CH3, CH2 plus. This is my nucleophile, but where is it gonna go? So if you look at this molecule, this is orthopara director, So this position is too crowded. The one on the left is crowded. So that means that this is not as available because you have too much stuff in here. So this position is ortho to this. So I don't want it here. This position is ortho to that one, but para to this. So that's okay. I can attach the electrophile in here, or I can attach it here because it's para to this, ortho to this, but not this. Because that's gonna be meta to this, meta to that one. Do you understand the logic? Maybe.
Freaking fly. Flew right past my face.
Okay, so Cl, CH3, like this, and then I'm gonna attach the CH2, CH3. So I repeat, the molecule was this, okay? So I have 4 spots where I can attach it. This, and that, right? The electrophile is CH3, CH2. So maybe I should do this. CH3, CH2 is my electrophile. CH3, CH2, and where will I attach it? So I attach it here, right? Okay. So again, there are 4 positions, this, and that. This one is too crowded. By steric effect, it's not gonna go here. Although it's still available because this is ortho to this, ortho to that one. This is ortho and ortho para directors, right? So these positions are favored, okay? Because this one is ortho to that one, para to this. This one is para to that one, ortho to this. But this one is meta to both. So it's not gonna go here. So I can attach it in here, and then I'm gonna get another product, which is going to be this. So CH3, and then Cl, CH2, CH3. Do you understand the reasoning? Yeah?
No, yeah.
Maybe. Okay? So this part, this will not be favored. That means that I will not make this. I'm not gonna make this. I cannot synthesize it, or I cannot make it because it's too crowded. So I can also just write it, so not form. I can also write it just like this, right? But it's not gonna form.
Okay, can you slowly explain why that area is too crowded?
Steric effect.
So between the Cl and the SCH3, why is that
They're
point
pushing.
too crowded?
Because I have it, it's like, how can I explain it?
Is Cl like stronger or something, or it can't be next to it, or
This
pushing.
is, okay,
how come it can be on the other side of the CH3 but it can't be on that side?
this is so close to each
It
other.
makes it like heavy, like tip over?
No.
Got to think of it like
It's,
that way?
it's
No?
occupied.
Okay.
It's like this is occupied, and this H, for the electrophile to go here, it has to insert between these two.
Mm-hmm.
So it's called steric effect.
Mm.
Crowded, this one not crowded.
Okay. There's too much
It's
on that
crowded.
side.
Too much activity here,
Okay.
okay? So
Yeah.
that's why this one is okay, and this one is
But then that bottom right corner, again, that's too much?
no, because it's far.
No, the bottom right. You have
This
an
one?
X. Yeah.
Okay, this one is not favored because the orientation is just gonna favor this and this.
The ortho.
The ortho, because this is ortho, para director, and then ortho and para to this. Ortho and para.
Okay, so we're looking at the CH3,
Yeah.
where we can put it by
If
the
you look at the
CH3.
CH3, if you look at the CH3, these positions are actually, this is ortho to this.
Uh-huh.
Ortho to that one, para to this.
Mm-hmm.
But this one's crowded, so that's not good
Okay.
position.
Because that CL's over there.
Correct.
Okay.
So if you're looking at the methyl, this one is okay and this one is fine.
Okay.
And now if you're looking now at this substituent, this is okay and this one is okay.
But the one on the right is not.
The one on the left, no.
The right. You had an X there earlier.
No, because that's meta to these.
Meta to those.
and meta to that one.
Okay.
So,
So it
it's
can only be ortho or para?
correct.
Okay.
So the same thing as this one, right? This one reinforces this, but you don't go here because this position is meta to that one and ortho to this.
Mm-hmm.
So you go here, okay?
Mm-hmm.
Not here,
Okay.
okay?
Okay.
It's like in Spanish.